All right, we're going to finish up Unit 2, and we're going to first go over writing formulas from names. So, ammonium phosphate. This is ammonium. This is phosphate, and you know your polyatomic ions so well. So you do the cross and the drop. Oops, parentheses here. So NH4 parentheses PO4. And you don't need a parentheses around PO4 because only one is required. All right, iron 2 oxide, Fe plus 2, O minus 2, so it would be FeO. Iron 3 oxide, would be Fe2O3. Lead 4 oxide, Pb plus 4, O minus 2, would be Pb2O4, which would simplify to PbO2. Calcium chloride, Ca2 plus, Cl minus, and it doesn't matter which way you write the numbers, just as long as you have the right charge. So that comes out to CaCl2. Potassium nitrate, K plus, NO3 minus, so that's KNO3. Magnesium hydroxide, so Mg parentheses OH2. Aluminum sulfate, all right, copper 2 sulfate, that's just 1-to-1, CuSO4. Again, no parentheses are required because only one polyatomic ion is used. All right, lead 4 dichromate, so Pb plus 4, Cr2O7 minus 2. So it's Pb2, Cr2O7, 4. And then this simplifies down to Pb, Cr2O7, parentheses 2. All right, sodium bicarbonate, that's baking soda, so Na plus, HCO3 minus, so it's NaHCO3. So if you look at a box of baking soda, it will have this listed as the active ingredient, or sodium bicarbonate. Zinc nitrate, so you get ZnNO3, 2. Aluminum sulfite, there you go. So practice, practice, practice. Tons of practice problems with nomenclature. So now we're going to work on naming molecular compounds. Molecular compounds are non-metal to non-metal. So you're looking at the right side of the periodic table. So molecular formulas are written with the less electronegative element first. We use prefixes here. So you have to be very careful switching back between ionic nomenclature, which we just saw here, versus molecular nomenclature. So what inevitably happens is students will say, oh, this is the one where I get to use prefixes. Usually students like naming covalent compounds better. It's a lot easier than ionic compounds. But I caution you. Watch, I'll show you what happens. So this is Carbon Tetrachloride. And then students will get something like this. They'll get PbO2, and they'll say lead dioxide. It's incorrect. That is incorrect. This is lead 4 oxide, and if you're not sure where I got lead 4, see the previous page, page 18. So I warn you. So one of the things I always encourage students to do when they're working on nomenclature problems, because on the exam in Chem 100 and the exams in Chem 1 and in Chem 122, ionic nomenclature will be mixed in with covalent nomenclature. And so one of the things I tell students to do is to always kind of classify it before you name it. So carbon's a nonmetal, chlorine's a nonmetal. Okay, well you can use these prefixes. All right, lead is a transition metal, oxygen is a nonmetal. So this is metal to nonmetal, that's ionic. So nonmetal to nonmetal, covalent. Okay, so let me give you these prefixes. I know you were just sitting on the edge of your seat waiting for them. One is mono. This mono is typically used when you have one of the second element, and it's not always used. So it's kind of, I'm okay if it's not used. But you see it with like carbon monoxide. Okay, but not monocarbon monoxide. It's just carbon monoxide. All right, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. Okay. So let's name some covalent compounds. So here's a good time to hit pause and work through these. I'll go through the first 2 and then you can hit pause and work through them. So the first one is carbon dioxide. And so you name the first element as it is, and the second element you add IDE. So just like we did with the ionic nomenclature. So this is carbon dioxide. Now, another thing that students can get caught up in is thinking they need to do the cross and raise with the covalent compounds. And so sometimes they'll say dicarbon monoxide, and that's incorrect. So when you're using these prefixes, this subscript stays with that, so that if you have 2, you're going to use di. Sorry, my highlighter doesn't show up very well here. Okay, the next one is carbon monoxide. And then sulfur. I have 2 oxygens, so sulfur dioxide. And then sulfur trioxide. And then dinitrogen oxide. I was thinking dinitrogen pentoxide, which we see a lot too, but it's just dinitrogen oxide. Now you can stop and hit pause, work through these, and I'll just continue going on over these. This next one, nitrogen monoxide, dinitrogen trioxide, nitrogen dioxide, dinitrogen tetroxide. Now notice with this one, the prefix is tetra and you're adding it to oxide. So tetra plus oxide gives you this weird vowel deal. So what you do is you eliminate the first vowel. If you ever have a situation develop where you have 2 vowels. The other thing I want to point out about number 9 is that it's very easy to want to simplify these because you have just come out of ionic nomenclature and you're thinking, oh, this can be divided by 2. It should really be NO2. You do not simplify with covalent compounds. You leave them as is. So be careful with that. All right, number 10, dinitrogen pentoxide. Again, it would be pentaoxide, but we took off the A because it was to make it less awkward. 11, phosphorus Tri Chloride. I used to use this a lot in graduate school. It's very stinky and smoky. All right, number 12, carbon tetrachloride. This chemical was not in use when I was in graduate school because it is a teratogen, can cause a lot of different weird cancers, but it was used for some time and in labs, and you know, my advisor, who was older, would always say, oh, we used to use carbon tet all the time. There's nothing wrong with it. You don't have to wear gloves. You don't have to use hoods. But yeah, the weird cancers would develop among his classmates and everything. So, but that's not going to be on the test. Just kind of interesting. 13, phosphorus tribromide. Okay, moving on. Now, on the exam, you are going to have ionic and covalent nomenclature mixed together. So it's really important that you get a firm foundation in practicing these over and over and over again. I am not going to say, name these ionic compounds. I'm not going to say, name these covalent compounds. They're going to all be jumbled together. And that is what is expected of you in future chemistry classes. So I don't want to coddle you and say, oh, it's a prep course. You don't have to name it. You don't have to know, distinguish them. But I want you to, because I want you to be well prepared for your next chemistry course. So the next 2 pages go through a lot of nomenclature. And this table would be hard to do in one sitting, I think. You know, do 3, 4, come back, practice them. You can always come back and review this lecture again and fast forward to whatever answer you want. But for me, you know, I've seen this so much that it's just second nature. I want it to become that way for you. I want you to immediately, when you see something that needs to be named, I want you to classify it as ionic or covalent and then name it. Because inevitably, coming off of covalent nomenclature, you're going to say, oh, that's iron trichloride. It's just like phosphorus trichloride. My professor worked with it in graduate school. No, it's not, because this is ionic. It's going to be iron 3 chloride. So iron 3 chloride. So with all of these, you're going to, you know, work to classify the type of bond and then name it. So what I don't want you to do with these next 2 pages is that I don't want you to just listen to this entire lecture and copy these down and not digest it and not practice these, because it's very important to practice these. Because like I said, on the exam, this is a big part of your grade. In Principles of Chemistry, I know nomenclature comprises at least 30% of your Unit 2 exam. And there are other questions about nomenclature too. So be sure that you're not just copying this down, because it's not going to stick if you do it that way. So I'm going to continue going through these and explaining them. I would prefer that before you listen to me do this, that you've attempted them. So I'll get off my high horse now. Okay, this is ionic, zinc, chloride. Why don't I use a Roman numeral? Because zinc is a transition metal with only one little number, so you don't say zinc 2 chloride. The next one is ionic 2, sodium chloride. The next one's covalent, carbon tetrachloride. Ionic, calcium sulfate. Ammonium sulfate's ionic. It's NH4, 2SO4. Ionic, magnesium hydroxide. Next one's covalent, and that's H2O. Hydrogen iodide is covalent, and that's just HI. Covalent, phosphorus Tri Chloride. Ionic, magnesium hydroxide, H2O. Hydrogen iodide is covalent, and that's just HI. Covalent, phosphorus Tri Chloride. Ionic, magnesium hydroxide, H2O. Hydrogen iodide is covalent, and that's just HI. Covalent, phosphorus Tri Chloride. Okay, covalent CO2, covalent xenon tetrachloride, covalent PF3. That is an angry chemical. I would not recommend working with that. Okay, next one, dinitrogen pentoxide, covalent dinitrogen, so N2O5. Be careful. Remember, with covalent compounds, you do not have to switch. You don't do the cross and raise, the cross and drop. You just list it as they are. Next one, covalent dichlorine heptoxide. Next one, covalent. Note, a lot of times students will say, this is sulfate ion. I know it is, Professor Clark. You were wrong. It is not sulfite ion written like this because it has no charge. So this is sulfur trioxide. Okay, the next one's ionic, potassium oxalate, so that's K2C2O4. Ionic, iron 2 dichromate. All right, mercury 2 carbonate, that would be ionic, so HgCO3, covalent, hydrogen chloride. Next one, covalent, silicon tetrachloride. Okay, covalent, silicon diiodide. Kind of a weird spelling. Okay, and next page. Sodium sulfide, ionic, and that is Na2S, ionic. Barium iodide, ionic. Gold 3 iodide, that's a 3. Okay, ionic. Copper 2 oxide, ionic. Magnesium chloride, MgCl2, covalent. Phosphorus dicoxide. Crazy name. Okay, covalent sulfur hexafluoride. Covalent dichlorine heptoxide, Cl2O7. Covalent nitrogen monoxide, ionic. Ammonium phosphate, ionic. Tin 2 nitrate, covalent hydrogen bromide, covalent boron trifluoride, covalent carbon monoxide, covalent SO2, covalent dinitrogen tetroxide, covalent phosphorus Tri Chloride, ionic plumbic dichromate. So ic be the higher charge. So this is Pb plus 4, Cr2O7 2 minus. We're going to simplify this, so it's going to be Pb Cr2O7 2. Ionic lithium phosphate, ionic Na3N, ionic nickel 2 bicarbonate. All right, so that concludes the ionic covalent nomenclature table. If there were some that you missed or some that I missed, be sure to let me know. But practice, practice, practice. You can always print this out again and practice some more. It never hurts to practice this. You can never practice enough. Okay, we have a little bit more nomenclature left, and that is naming acids. Not dropping acids, but naming acids. So there are two types of acids that we're going to learn how to name. And they're naming binary acids. So two types are binary acids and oxo acids. So I'll give you an example of what a binary acid is. This would be like HCl. And so they're pretty straightforward. You're just going to say hydro and then chloric. So it's hydro plus the name of ion plus ic and then space acid. So this is hydrochloric acid. Okay. Now, oxo acids, on the other hand, are ones that contain hydrogen and oxygen. So acids are a source of H plus protons. So what you'll find in common with all the acids that we see is that they have hydrogen, 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 hydrogen. So the oxo acids that we're going to learn how to name come from your polyatomic ions. So you have, I'll give you two examples. So HNO2 and HNO3. These are examples of oxo acids. And what you have to do is look at the polyatomic ion from which they come. Ooh, I got Christmas colors going on. So this would be NO2 minus. And so naming acids requires a firm foundation of polyatomic ion nomenclature. So you're probably thinking, she's trying to torture us with polyatomic ions. I'm not. That's just how it is. But makes it so much easier if you know your polyatomic ions. Okay, so this is nitrite ion. Okay, and this guy over here, remember, is nitrate ion. Okay, so with acid, oxo acid nomenclature, it goes ite to us and 8 to ic. What does that mean? So this is going to be, since it was nitrite, it's going to be nitrous acid. So this is nitrous acid. And this, it was nitrate, it's going to go to ic. So it's nitric acid. Okay? So, now for some practice. All right, so this one, that's one we just did. Look at the polyatomic ion from which it came. So it's NO2 minus, that's nitrite. So this is going to be nitrous. So it might help if you write ite to us, 8 to ic, your little cheat sheet. And that's a good thing to put on the top of your exam. Okay, so this is SO3 2 minus, that's sulfite. So this is going to be sulfurous acid. CO3 2 minus is carbonate, so that's going to be carbonic acid. You have that if you like to drink soda, carbonic acid, that's the carbonation. Fizz. Okay, this guy is kind of in disguise. C2H2O3 minus is acetate ion. So acetate is going to go to ic, so this is acetic acid, and acetic acid is vinegar. Okay, this is your binary acid, so it's just going to be hydrofluoric acid. Okay, ClO2, that's chlorite, so it's going to be Chloric acid. This will be, ClO3 will be chloric acid, and NO3 is nitrate, so it's going to be nitric acid. Okay, so my instructions are incorrect. It should be write the following acids. Okay, so phosphoric acid, that is PO4 3-, so it's going to be whatever the charge is on that polyatomic ion, that's going to be how many hydrogens you put, so it's going to be H3PO4. Okay, acetic acid, acetate, so C2H3O2-, that will be HC2H3O2-. And usually with acids you write the H plus H first, so even though you have hydrogens in acetic acid, we still write that one H in front. Okay, hydrobromic acid is just going to be HBr, you're dealing with just Br-. Sulfurous acid, okay, so look at your cheat sheet, that comes from sulfite. All right, so what is sulfite? I don't know my polyatomic ions. Learn them. Hello, learn them. Okay, H2SO3. Seriously, your next chemistry class will be so much easier if you know your polyatomic ions. And then you'll impress other students in your class too, like, oh, you know, I just learned these. Just, yeah. Anyways, chloric acid. So ic comes from 8, so that's going to be chlorate. Remember, chlorate is this guy, so it's going to be HClO3, and then nitrous comes from nitrite, NO2-, so HNO2. And we're done with Unit 2. So lots of nomenclature in Unit 2. If I haven't emphasized that enough, work on your polyatomic ions, work on nomenclature, work on your homework problems, study. Try to make up funny things so you can remember your polyatomic ions. And did I mention that you need to learn your polyatomic ions? Just making sure it's clear. Anyways, that's all for Unit 2, and we'll practice these in class. All right, on to Unit 3.